Hopefully everybody downloaded the notes. I've already put the grades in for the assignment from last week. You'll see that in your e-class tomorrow. We're continuing those circles today. Yes, we're all done. Yeah. So we're going to continue with circles, and if you remember, if you did the first week's assignment, there was a couple topics sprinkled in there that I hadn't had a chance to go over yet. I just control what Khan Academy does sometimes. Those were sprinkled in. We'll look at the Khan Academy videos. It's not the most difficult concept. Today it isn't the hardest thing ever. But nonetheless, this isn't the first time that you guys have seen this. There's two main angles within a circle that we study. Okay? The first angle is made up of two chords. So I have two chords that have a common endpoint, right? And they meet at a vertex on the circle that has a name. That is called an inscribed angle. If I have two radii, radiuses that meet at the center of the circle, that is called a central angle. And what we want to learn is the relationship between those angles and the arcs that they intersect. Okay? When we talk about part of a circle, okay, so like, what do we call the entire distance around the circle? We call it the entire outside of the circle. Right? So if we talk about part of a circle, that's called an arc. And there's going to be two types of problems. One is this week, and one I believe is next week. That we're going to deal with. And you've got to be careful with these words, right? We're going to talk about arc measure, and we're going to talk about arc length. I'll say it again. Arc measure and arc length. When we talk about arc measure, arcs are measured in the same unit that angles are measured in. What unit do we measure angles in? Medimos ángulos. In degrees, sure. If you get to algebra 2, you'll be introduced to radians, which is another unit. But for right now, sure, we measure in degrees, right? But when we get to arc length next week, that gets measured in units of distance, like inches, feet, meters, miles, whatever. It's like a distance. But this week, it's just going to be arc measure. Now, the way we get that arc measure can depend on these two types of angles that are inside of a circle. So we have to learn the relationship. So here's the way I teach it, right? Think of this as like being Pac-Man. Here's the hungry. Okay? Another Pac-Man. And if you look at in the jaws of Pac-Man, inside the mouth, there's a piece of a circle, also known as an arc. If you know the degree measure of an inscribed angle, if it's an inscribed angle that's creating that mouth, the arc that it is intercepting, now I say eating, and eating is formal, but really the correct word is intercepting. Okay, the arc that's in between its jaws, the arc that it's intercepting, is going to be double the measure of the inscribed angle. So like if you look at the example, if I remove all this scribble scrabble that I have on the board, okay, let's look at this example. What is the measure of the inscribed angle? That first example. What is the measure of the inscribed angle? It's 60 degrees, right? Now if you look in between the jaws of that inscribed angle, what is the measure of the arc that is in between the two endpoints of that inscribed angle? Somebody other than Denise. You can just down here. Imagine. The relationship between an inscribed angle and the arc that it intersects is that the arc is double. If you go from here to here, it's times 2. That's the relationship when an angle is inscribed. So Jeanette just told us that the inscribed angle is 60 degrees. So how many degrees would be on the arc that's in between its mouth? Inside of its mouth. Literally on the board. Yeah, it's 120 because it is times 2. Now, the only thing now you have to remember is that if you have a central angle, like you really, the biggest thing today, and I don't even think it's that big, is that you need to differentiate between the inscribed angle and a central angle. So if you have a central angle, which is an angle that's made up of 2 radii, okay, this can also intercept an arc. It can still have an arc in its mouth, but now the degree measures are the same. The same or they're equal. The same amount of degrees. So like in the example that we have there, I don't know how long the resolution is, you can see it on your screen, but the central angle is 128 degrees. So we can use this information now to make some properties. There's a couple of other things that you need to be aware of going forward. So like here's the first one. What type of angle did I just draw? Inscribed, very good, because it's made up of 2 chords. What type of angle did I draw there? Blue, what type of angle do you see in blue? What type of angle do you see in blue? Also inscribed, it's also made up of 2 chords. So 2 different angles. They have 2 different vertices and they're made up of there's 4 different chords that are drawn. So these are 2 completely different angles, but what they have in common is that they are both intercepting the same arc. They have the same arc inside of their jaws. So what we learn is that if that's the case, if you have 2 different inscribed angles that are eating the same arc, those 2 angles are congruent. The first property we have to learn. Any questions on that one? Here's the next one. What type of segment did I just draw there? What type of segment did I draw there? Tangent. That is a diameter. Well, it's a chord that happens to also pass through the center. If you weren't sure, it's also some diameter. Okay? And what type of angle is this? Inscribed, sure, it's made up of 2 chords also. So what this tells you is that we have an inscribed angle that shares endpoints with the diameter, then that inscribed angle measures 90 degrees. Now here's the reason why. Okay? Because the diameter cuts a circle in half, right? So what we call the outside of that circle that's been cut in half, we call it a semicircle. How many degrees are there in an entire circle? When Mikhail goes up and dunks, and he turns a complete revolution in the air, what type of dunk do we call that? Not Ryan. Ryan can't dunk. How many degrees are there in a circle? 360. Well, I cut a circle in half. How many degrees are there in half of a circle? 180. And if we just learned that an inscribed angle is half, has half of the degrees of the arc that it's eating, right? Here's the mouth, it's just eating half of the circle. What's half of 180? hash brown facts. Good. Okay, you know the last one on this page is another property. If in a circle you have a quadrilateral, how many sides does a quadrilateral have? Just first semester geometry. How many sides are there in a quadrilateral? 4, or 4 as the kids would say. And that quadrilateral is made up entirely of chords. It's made up entirely of segments that start and stop on the circle. Then the opposite angles, the angles that are across from each other, are supplementary. What does the word supplementary mean? Fantastic. They have a 480, sure. And that's a little tricky sometimes because you're blending sticks and you put it congruent. And you just like opposite angles being congruent, like in parallelograms and stuff. But that's not the case. Opposite angles. Okay, so now what the second slide does now is we're going to talk more about different types of arcs. Okay? So what we have here, we have drawn here our central angles. And see, like, when we talk about segments, whether a segment is a chord or a radius or a diameter, when we talk about segments, okay, we learn that segments are named with 2 points, and then it's like a little hash mark. You learn that in right? Like, for instance, here in this first picture, if I wanted to go from A and stop at B, but just go on a straight line, and drawing a segment, this is what I would call that. I would call it AB with a little hash on top. But let's say I wanted to go from A to B, but go around the circle. Well, now that becomes AB with a little dome on top. That little dome is a symbol for arc. It has like a little hat on top. Now what you have to receive, if I start at A and end up at B, there's 2 ways to get there. There's a short way, which is what you see here in red, but there's also this longer way. If I were to do this, I would still start at A and stop at B. Okay? So we have 2 different names for those. And you're gonna, on the outside, on the circumference of a circle, you're gonna go from one point to the other and go the shorter way. Okay, the shorter way should be less than 180 degrees. That is called a minor arc. And the way that you would show that is what I showed you here, which is just a little arc symbol with 2 points. If you want to go the long way, which means that the amount that you're traveling is more than 180 degrees, you would need a 3rd point. And that 3rd point is telling you where to go to. So like if if I wanted to have an extra pointer and call this D, well I would have to now get that D and squeeze it in between the A and the B. So if we look at this next example here, and by the way this is called a major arc. If I wanted to start at A and stop at B but go the long way, I would need another point that I'm going through, in this case it's C, and that would be called AC, because a major arc gets named with 3 points, a minor arc gets named with 2 points. No questions there. Now, even though Ryan's not new, I know Ryan's asking a question right now. He's saying, but Mr. Romero, you talked about what happens if the arc is less than 180. You talked about what happens if the arc is more than 180. Well, what happens if the arc is exactly 180? Okay? And so we saw this example over here where we had a diameter that cut the circle in half. So how do you name it? And really, I don't have one solid answer for that because I've seen it both ways depending on the book. So like if you look here, DF is a diameter, right? So if I wanna start at D and go to F, really this is the way it should be. The way that you should be hitting a semicircle, this is the way I've seen it most often, is with 3 points. You treat a semicircle as if it were a major arc. So like D, E, F, we start at D, end at F, and go through E. But I've also sometimes seen semicircles named with 2 points. So I guess let's, for all intents and purposes, let's say if we wanted to describe this, since we have no other points there in the middle, you could still call it DF and get away with it, and it would still be a semicircle. Any questions there?
The words in the book that was reading. So James Dean, he created this character named People Cat that everybody loves, and he wrote a book about People Cat. Everybody likes that book so much. But then he wrote another book.
Here we talked about central angles already. How do you, if you were to construct a central angle, how would you make a central angle? What is a central angle made up of?
And so this book, he's the author and the illustrator. So lots of times authors will write a book and they write about the same character several different times. So we'll read lots of books this year like that. So today we learned that the title is the name of the author. The author is the person who writes the words in the book. And the illustrator is the person who draws the pictures. So just like all these things, we read them and then we did our own writing. That's what we're going to do today.
I have time. I don't know.
I need everybody to sit down.
Too far to do have to do this.
I need everybody ready to listen.
Most of the people.
We're going to read another book about people. This might be our last one for a little while. Not forever, but just for a little while. Because we're going to move on to some other books. But today,
You want to help?
we're going to read another book about people. So we're going to do our own writing about ourselves. Lots of times we read a book and then we'll
What is
learn
a central angle made up of?
and then we come up with our own writing. So,
What is a central angle made up of? Central angle, what is that made up of?
Oh, and what do you think is going to happen in this story? This is what we call a prediction. It's where you guess what's going to happen.
Okay, that's more of a fact about it. Yes, the vertex is in the center. What is it made up of? Like, what is it composed of? Central angle made up of two of these.
Okay, is that Owen talking though?
Like, this is easy for you.
Alright. Owen, what do you think is going to happen in this book? Unmute yourself, Owen. Unmute yourself. Okay, now we can. What do you think is going to happen? He's going to drive it through? That's a good guess. Alright, what do you think is going to happen in this book? Jordan, what do you think is going to happen?
Those things. It does start with an R, yeah. Yay! You did it! You did it!
Even let me. Could you guys hear that music playing?
Where do you think he's going to go on a train? Where do you think he would go on a train? Porter, where do you think he's going to go on a train?
Come on. Yeah, let's bring up the two right here. So you see here, all of these angles are made up of right there. They're all central angles. And let's see, they tell you that the measure of angle ABC is 85. So if I label this, the central angle is 85. And the first question says, well, then what is the measure of arc AC? What type of arc is that? Because it's being used with just 2 points. What type of arc is that? Equal that arc is O.
Where do you think he's going to go, Caleb?
It is a how many degrees are there between A and C? Short way. So this just happens to be the arc that this ABC is intersecting. This ABC is eating that arc. So what is the relationship between the central angle and the arc that it intersects?
Yes, very good. All right, so we know he's going to go on a train. Now we got to find out where is he going. All right, so everybody look and make sure your mute is everybody listen to the story, okay?
I need to listen. No talking, listen, baby. What is the relationship between the central angle and the arc that intersects? And literally your arrow. What is the relationship?
people are not muted, so we can hear people in the background.
They are congruent. So how many degrees would it be?
Okay, here we go. So we're going to
All
read
right.
this book.
So now they want to know what is the measure of ABD. So here's
You're going to notice when I
ABD.
read, we go from
What would be the
left
measurement of that
to
angle?
right.
Well, if I knew how much there was here, this also looks like a minor arc. If I knew what the measurement of this minor arc was, that would be enough to give you also congruent. And sure enough, they will tell me that minor arc AB, the shortest path from A to B, is 110 degrees. So how many degrees would there be in that central angle?
Now I'm going to use mine.
10 degrees would there be in that central angle?
The cat is good. His grandma gets to ride on a train. Raise your hand if you've ever ridden on a train before. Any kind of train.
How many,
All right.
how many degrees are on that central angle? Kira, I want to hear your answer.
How they label their pictures. This building is the train station. And over here they label this. This says tickets. The mom.
Here on the outside is 110 degrees in that arc, so how many degrees are in the central angle?
She gives one to me and one to brother mom. So who is the other ticket for? Maria? She bought 3 tickets.
Any questions?
And she gave mom a ticket. Who's the other ticket for?
Alright,
Maria?
already moving along there. Alright, now let's just look at a lot of examples. And really, it's going to be a lot of examples for the rest of the week. We got today, tomorrow, Wednesday, another couple weeks. And we can't finish that. I probably will finish by tomorrow. Thursday we'll finish up whatever we haven't finished up by then. Friday will be like the way last time. KM is a diameter. Okay. That's telling you that it's cutting the circle in half. As far as on the outside of the arc, it's 180 degrees above it and 100 degrees below it. So here, we want you to label each arc as major, minor, or a semicircle, and then find the measure of the arc. So let's start off with here with KL. Is KL major, minor, or a semicircle? It is minor. How do you know it's minor? You know, as you know, tell me what it is. How do you know it's minor? Okay, you could say that. That's fine. I'll take that. But let's say that we couldn't see the diagram. How do you know just by the way it's named that it's minor? It's being named with only 2 points. Very good. Okay, so I want to know how many degrees are there. I know that because these are all central angles here. Central angles are congruent with the arcs that they intersect. If I knew how many degrees there were here in that central angle, it would be the same. And even though they don't tell me directly, I do know that the angle right next to it, together they make up a line. It's called a linear pair. That angle is 125 degrees. What is the relationship with the other angle in a linear pair? If you have a linear pair, what words can be used to describe the relationship? What one single word can be used to describe the relationship in a linear pair? It does start with an S, that ends with an supplementary. Supplementary, so that means they add up to 180. So that means if I want to find what's missing, I have to subtract it from 180. What is 180 minus 125? 180, menos 75. Hey, Mohammed! Homeboy, yes, good job, man. Thank you. 65 degrees, good. Alright, part B there. Is that a major, a minor, or a semicircle?
Lexi Taylor, stop unmuting yourself. Stop touching.
Let's see, KLM, it could be 3 points. It could, I can tell by looking at it. Just I only have to look at the diagram. It's either going to be major or it's going to be a semicircle. But yes, to know the difference, I have to look. And so starting at K, ending at M, and going to L, it does share the same endpoint to the diameter. So who was that, Ezri? She is correct. It'll be a semicircle. And even if I didn't have a diagram, how many degrees do we always know there are in any semicircle? Let me see what's going to say that right now. Okay, how about KML? So starting at K, ending at L, but going through M. Is that major, minor, or semicircle? That either has to be major or semi. In this case, it's more than 180 degrees, it is major. How would I find out how many degrees? Very good, because when I go around that path, from K to M, I know that's half a circle. They don't have to label it. I know that's 180 degrees. And then if I go 125 more, what is 180 plus 125? Mohammed has a calculator? What is 180 plus? Very good. Or as the people from my hometown say, 305. And then finally the last one, ML. From M to L the short way, major, minor, or semi. It is minor because it's less than 180 degrees. Good. How many degrees there? 125. Any questions on that page? Okay, so what we just finished doing now, whether you knew it or not, we just did it on this phone here. Okay, pay attention to the next page because it's going to elaborate on what we just did there. Here you see a circle. What types of angles are all those angles that are drawn inside the circle? What are all those types of angles that are drawn inside of the circle? What are all? Yeah, those are all central angles, right? So now look at what happens. Say, look, I want to go from A to C the short way. And, even though there's a B in between, it doesn't matter because it's still, the shortest way to get from A to C is this way. So you wouldn't name it ABC, you would still call it AC. It's still minor, but because I have to go through B and because of the way it's labeled, how would I find that arc measure? How would I find the measurement of that arc? And what did you get on that problem in the last one? You would add them, yeah, you would add the two small numbers, A, B, and C. And 60 plus 82 is 142. So if you just exercise them, it's something called arc position posture. So if you want to go home and impress on, I guess you will. If you want to impress on your friends today on your Zoom post, just tell them that when you add two adjacent arcs, two arcs that are next to each other, that's called arc position posture. Okay, so you're going to teach the add to at least 6. Any questions there? Okay, how about ACD? I want to go from A, I want to end at D, but I need to go through C, so this is a long way. How can I figure out how many degrees there are there? Benjamin, pay attention, she might call you. Come on, somebody tell me, how would I find how many degrees there are? ACD. You would add 60, 82, and 100. What is 60 plus 82 plus 100? How many? What is the answer? And then finally, the last one on this page. Let's go from A to D, the short way. I want to know the arc I'm intercepting, but And I'm not telling you.
Sometimes when
Any ideas?
a page ends like that, we are going to predict what we think.
Yeah, that could happen. That would absolutely work. And you know what? And now that you mentioned that, I might have done something wrong this morning. Because you're actually put the wrong answer this morning. That would probably be the best way to see. Because this morning I got fooled by this picture, and I thought that this was a linear pair here. That earlier, and I was looking at resistance. That's the B120, but what I failed to do is, well, if that's the case, I should be able to add up all the degrees and get 360. And if I were to do that, that wouldn't actually be the case. So actually, the way that you described it, which is to say, hey, let's get all these three that we already have and take it away from 360. 360 minus 242 is a 118. Would be the way that who said that? Was that? So any questions on that page? Benjamin, did she call on you? Yeah. Did you unmute it? What type of angles do you see drawn in this circle? What type of angles do you see drawn in this circle? And look at central angles. And the reason why I'm not, I know it's boring, but the reason why I'm asking you for attention central angles and the way that they relate to the arcs is the same. Once you get the inscribed angles, you have to double the inscribed angles to get the arc.
Dogs or ducks?
That's why people repeat it so you don't get confused. So let's go with measure of minor arc, arc cube. So from R to Q, the short wave, how many degrees are there? It is 73. It's being intersected by a 73 degree central angle. 73 degrees. How about minor arc MM from M to N, the short wave? Oh man, they're not telling me, but who the hell is doing things here? Here we go. Hash brown TBM. What do you call angles that are across from each other in an intersection and therefore are congruent? Close. It does not start with a V. So first, vertical. Very good. So that means that this is also 73, and therefore how many degrees are there? Alright, what is the measure of arc and RQ? So starting at N, ending at Q.
We talked about how whenever an author writes a book, they put characters in their book. Characters can be the people or the animals in the story. So tell me, Riley, who was one character in this book? Who was one character in this book?
Ryan, how are you?
Pete the cat. All right. Who was another character in this book? Reese.
Ryan, you want to answer it? Go. Ryan wants to answer. Ryan said something for the first time.
Reese is another character in
Okay,
this book.
I'm giving it to you. Go ahead, then, Esmeralda, you take this one. What would you do? You're taking too much here. How many degrees are there? From N to R is 180, right? So then just add the 73 on top of that. So then 283. It's possible, yeah. Especially in geometry, that's one of the things. A lot of times there's more than one way to get to where you're trying to get to. Absolutely. All right, Ryan. Now it's your moment to shine for the ladies. PQ, minor arc. Little amount of degrees. How many are there? How did you get it? Right. How many degrees are there here? Facts. And so if I get all this 180 degrees, I take away this and this, right? Because those are the same. Would then just that be left over? So what's 180 minus 81 minus 73? Once again, his neon color.
Sanders, who was another character in the book?
That seems about right. Yeah, I see. Well, we want
All
to
right, Aaron, who was another character in the book? Did y'all see how I like how
I think this is where I stopped with.
That's what you're supposed to do.
Yeah, this is where I stopped with second, but they go faster than you guys. So I actually want to go a little further with you guys because I'm pretty sure I can catch up with them tomorrow. So, this diagram is a little bit more tricky because we have all types of angles here. We have central angles, which are made by radii. Yeah, you can see some radii here. Radius, 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 radius. And we have some inscribed angles that are made by chords. So there's a whole lot of stuff going on here. Okay? Let's see if we can get what they're asking us for. What is the measure of PMO? So let's see, PMO. What type of angle is PMO?
Very good. So in the book, we have
What type of, this is an angle, this is not an arc, this is an angle. What type of angle is PMO?
There were two other characters. Anybody know who the other two characters?
How many degrees is what type? Well, two
You know
types
who
of
the
angles.
other two characters were?
It is a central angle, and if a central angle is congruent to the arc that it intersects. How many degrees are in that angle?
Conductor and the person who drives it. Who is that person?
How about QMP?
Conductor and the engineer. Very
What type
good.
of angle is QMP?
Now, remember last week we talked about
That is also a central angle, but let's see, they don't tell me how many degrees there are here. But they did say, you know, I didn't read it before, but it's always in there, that NP is the diameter. So that's cutting the circle in half. How can I know how many degrees there are there?
The setting of our story. Remember we talked about the setting is where they are or where the story takes place. What was the setting of the
How
story?
can I figure out how many degrees there are just on the little piece here?
Where were the characters in the story? They were where?
Very good. Subtract 118 from 180. Good. 118 minus 180. Ryan can raise against Muhammad. And what do we get? 62? Good. How about the measure of minor arc ON? So from O to N, this short way over here. That was probably more than one way to do it, but I would do it. The diameter. All 180. I'll find this piece. Very good. 180 minus 68 gives us. Benjamin, what are you doing?
What else did we read that he did on the train? Porter, what else did he do?
All right, and then finally, from this page. And so from P to N, going through Q. That's pretty simple. How many degrees are there? How many degrees are there? Thank you. Also known as? Also known as? Also known as? Call 180 degree arc. Word for 180. Right, a circle that contains two congruent central angles will have congruent corners, right? So this telling you that if I have a central angle over here and another central angle over here, I were to connect them with chords, those chords would also be congruent. Kind of obvious, but that's how we give it a name. There's probably suppose that CD is 5x minus 3, so not the arc, but that segment is 5x minus 3, and AC, which is here, is 7x minus 17. Find x and find AB. How would we find x? When you want to solve for a variable, you derive equations. What equation can we use to help us solve for x?
And he was taking a trip to Grandma's house,
What
right?
equation can we use to
So what
help
we're
us
going to do
solve
today
for
for
x?
writer's workshop is I want you to think about at the trip
So that 5x minus 3 is equal to 7x minus 17. Depending on the teacher you had, they might have shown you different ways to solve these. A lot of them had equal algebra 1. So if you there's like a little wall there, and when it's linear, which is not reciprocated to all exponents, we move all the variables to one side, and the x to one side. And now the x's are taken over the right side. That's natural. So what variable did I have to get rid of?
now. Right now, nobody's writing.
The x's move over to the right. Who are they going to kick out? If all the x's move over to this side, to the right, who doesn't have an x on one side? Please say that. This side over here, who doesn't have an x?
You're going to write your name.
Negative 17. The way that you show it might look a little bit different than me. It will look the same as the next line. It's the same line 1. We should all get that. 4 is equal to 2x. Depending on what side you have it on, you might say negative 2x equals negative 4. So once you solve, you're going to end up with 2 equals x. So that's the answer to the first question. How would I answer the second question? How would I figure out what is the length of AB? You want to find the distance of the center, you just write the points, you don't put any symbols. You will be doing 7 times 2 minus 17. Does any of you think that
Tell me the name of the letter. What letter makes the now?
oh, I wrote it wrong, actually.
Alright, Edna, what letter makes the sound?
Sorry, I'm confused. I just wrote it wrong. It should have said 5x minus here.
So at the top of my paper.
Alright, but everything, all the steps are the same. Now, it's 7 times 7
Now, sometimes what we gotta
minus
try to do is not stretch
17 minus 17
somebody
is
looking for the N sound out. Correct.
They were then to ask you to find CD, would you have to substitute again?
Sound.
If they don't want to put on the CD, would you have to substitute again? Oh, why?
Alright, so I'm gonna write
Yeah, that's what you're doing.
right here for
Alright,
alright?
this is the last one. If the measure of arc QR is equal to the measure of arc ST, so QR, ST, will tell you these two are the same, find the measure of angle QPR. So find this right here. What equation can I use to solve for x? Benjamin, don't touch. What equation can I use? If the arcs are congruent, the central angles are congruent. So what equation can I use? What was that, Amici? You said 4x plus 25?
Ferris wheel.
On one side,
Emerson, what letter makes the
5x, I get 25 equals x. But they weren't asking me for x. They were asking me for the measure of angle QPR. And QPR is here. So how would I find the measure of that angle?
alright, so what letter makes the
I will substitute the 25 back into the x. So measure of angle QPR is
Every reason what makes the cell.
Before you leave, let me make sure I got the attendance right. Calling parents lately. I want to make sure I got it right.